This is the Schneider Electric Lexium MDrive hybrid stepper motor. What makes it a hybrid is the algorithms and the computer controls to make it act like a servo motor. If you try to pull it out of position, it'll bounce back. Feels a lot like grabbing the shaft of a servo. It's currently set at 25% holding torque, but the torque for the size of the motors are very impressive. This is a NEMA size 23. It's available in a size 17, NEMA size 17, 23, and 34. It comes in a couple of different connector options. This is the pluggable version, power, inputs, outputs, and my Ethernet port, a couple of diagnostic LEDs. And it also comes in a M12. I like the motor because of how easy it is to work with. For setting up the Ethernet port, they provide a software package. This is the Lexium MDrive software suite, and here is the Ethernet interface setup. So I can pop into the Ethernet setup. I have this all-important window here in the lower left. If I power cycle the motor, the IP address shows up there, so it's difficult to lose a motor. They send out broadcast messages on power up to announce their IP and serial number. And of course I can change all of that right here using this software, as well as many other configuration and test utilities for the other protocols. If I want to, I can use their program for their software for programming and communicating with the motor. This is a development window with a program I've created to cause a revolution forward and a revolution backwards. And then I have downloaded that program using their little terminal window. And then of course if I execute the program, you can see the motor rapidly making a forward and then a reverse move back and forth. One of the neat things though is, again, following the theme of easy to implement, you really don't need their software packages. Everything that you can do, here I'm at a command prompt in Linux. And in this case here, I've connected to the motor on their text-based language port on port 503, where I was easily able to connect, cause a motor rotation, ask it for its current position, and close the connection. Just as well as from the command prompt here, I'm sending a Modbus TCP. I'm asking it to do a revolution, and you can see the motor making a revolution. This is port 502, the standard Modbus port. Again, another rev, and then following that theme, you can also use Schneider's operator displays, PLCs, whatever you have to easily communicate with this thing over Modbus. In this case here, I've gone into Video Designer, created an operator screen monitoring the position and giving the ability to slew the motor or jog the motor. Video Designer supports simulating, so I don't actually have to have a panel for this test. And so I simulate it. There's the motor's current position. I can set the thing into motion at a predetermined speed. I wrote it into the button, and then stop the motor. So just a very easy motor to work with, and something that I think a lot of people would have applications for. Thank you.